Okay, we're going to look at a quick lesson on histograms, just the basics and what is it. And figured in this lesson I would do just a quick Google search on the word histogram, and we can take a look at what the results are and the image results that we get. And basically, when you do a search on histograms, it looks like, hey, here's what we get. And I think hopefully in your mind you're thinking, hey, that kind of looks like a bar graph. And really, histograms are kind of really a form of bar graphs. And these are just a bunch of examples. So we need to distinguish what the differences are here. Let's talk first of all about shapes. Shapes in histograms, shapes in data in general. This blue one right here is really skewed left. Skewed left again, remember, means that it's really drawn out on the left side. There's a lot of different or more odd data on the left, stretching the graph out quite a bit. Okay, so we have some skewed left data. We could find some other shapes here, general shapes like this one here, heights of 30 people. This one is skewed right. We could have stretched out on the right more, a little more odd data on the right. We have things that are symmetrical or somewhat symmetrical. This graph here is pretty symmetrical, kind of pretty much all centered around the middle. And then we have the other type, which is called bimodal, or we could take a look here and see if we could find some things that are bimodal. This one here would be bimodal. It's kind of two bumped in a sense, or two common, two modes, two common areas, one here, typically being on the two ends, the left and right side. Okay, so those are just some ideas as far as shape goes when we talk about discussing what the shape is of these histograms and their data. But let's take a look at this one, the heights of 30 people. We'll zoom in on this a little bit and take a look at what's going on here. In this picture, this histogram, someone's collected some data and they've measured the heights of 30 people. And we're not really going to use a bar graph in a sense where we're going to say, hey, here's everybody that was 139 centimeters. Here's everybody who was 140. Here's everybody 150. Instead, what a histogram does is it really combines. It puts people in categories. It says, let's just look at everybody from 139 to 149. It says, let's group them all. So that's one of the big things about a histogram. It says we're going to really have a range of values here for this bar. We're going to go 139.5 to 149.5. And the key thing on this is each bar represents all the numbers between these two. And one key thing to know is the 139.5. If there's a person that actually measured 139.5, they are included in this bar. If there's somebody that measures 149.5, it's very important to know they're actually included in the next bar. So when you look at bars, and technically I'm using the wrong terminology for a histogram, we'll get there. But when we look at the bars, which in statistics are called bins or classes, in each bin, the left number is included and the right number is not. Okay, so 159.5 belongs in a yellow bin. Okay, that belongs in this one. So it's very important to remember the left number is included in the next bin or class. And when I get to my next number, it just goes to the next bin. So some other things to think about here is that basically, yes, it looks like a bar graph. It's called a histogram because each bin, no longer called a bar, contains a range of numbers, includes the left side, not the right side, and we basically show how many things fell in that category, that bin, or that class. So what we're looking at here when we talk about histograms, there are some key things to look at. Let me get rid of some of these markings here. What we're looking at is a histogram. They look like a bar graph. They're not. It's not called a bar graph because there's a range of numbers. A bar graph technically is categorical data. A histogram, we have more numerical data because we have a range of numbers we're including in each bar. That's one of the big differences. Okay, so a histogram is a type of bar graph where the bars have to be next to each other. Okay, meaning when I look at my picture, these bins are all touching. Like right here, the green and the yellow are touching, and here the green and the yellow are touching. And that should occur. In bar graphs, a lot of times there's spaces between those to separate the categories for each bar. Okay, so they should be touching, unless of course we have a bin or a class where nobody fell in that category, then we'll have a blank space. Okay, again, they're called bins or classes, and both the x and the y-axis are numerical. Just some key thoughts.